Hi everyone, I am Kareem, and in this two-part series I will implement this game. Then I will try to teach the computer to play it using genetic algorithms neural network. The game objective is to jump over obstacles and to travel as far as possible. To follow along, you will need to be familiar with genetic algorithm and neural networks. Also, I will use Java and Spring Boot to build the genetic algorithm and neural networks, and will use Unity and C# to build the game. The way I'm gonna implement the genetic algorithm is that on game start I will generate the first population of individuals. In this example, each box represents an individual. Also, I'm gonna call them creatures. The first population of creatures will have random genes. Then I'm gonna leave them to try and jump over obstacles. And after all of them die by crashing into an obstacle, I will generate the next population. To generate the next population, I will do selection, crossover and mutation. Once the creature is created, I will keep checking if it is on the floor to get the distance to next obstacle. Then I'm gonna give this value to the neural network. I will use the output returned from the neural network to set the jump velocity of the creature. So if the neural network returns 1, the creature will jump as high as it can. If it returns 0, the creature will stay still. Also keep in mind the creature will keep moving in forward direction at all time. If the creature hits an obstacle, I will calculate the fitness and will destroy it. The fitness will be the total distance traveled for this creature. The genes in this example will represent the neural network weights. These weights will affect the output of the neural network. And the goal of this algorithm is to try and find good weight values that will make the creature neural network act correctly to different inputs. I will build the genetic algorithm logic and neural networks in Java, and I will expose 4 REST endpoints with Spring Boot. Then I will build the game in Unity and C# and will call these endpoints to let the computer play it. So I started by creating a new Spring Boot project. I used this Spring Boot CLI tool to create this project. I will add some dependencies that I'm gonna need in this project. So I have these dependencies here. So I'm gonna use deep learning for J, which will provide the neural network. Also, it requires this library, and I'm gonna use this DevTools library as well. And I need to define the deep learning for J version. And at the point of creating this video, this was the latest version. I will start by creating the creature class, which will be the basis for our genetic algorithm. So each creature will have an instance of the neural network, and I'm gonna use multi-layer network from deep learning for J. Also, I'm gonna define here the number of inputs and the number of outputs. Whenever we are creating a new instance of the creature, I'm gonna create an instance of the neural network. And I have this method here that I'm gonna copy. So to create a neural network in deep learning for J, first we need to create an instance of this configuration. And this defines the configuration of this neural network. So what I have here is just 2 layers. The first layer is the input layer, and it will have only 1 input. And the output layer, it will have 1 output, and I'm using this activation function, which will return values between 0 and 1. So later on, I'm gonna play around with this configuration. After creating an instance of this neural network, I will need to initialize this brain, and I need to initialize it with some weights. So initially for the first population, I'm gonna initialize the neural network with random weights. But for next populations, we will need to give the weights ourselves. So I'm gonna create here another constructor to do that. So this init method takes an ND array. And an ND array is basically an n dimension array, and the weights is a 2D array with only one row and n columns, where n is the number of weights we have in this neural network, and it depends on the number of layers and the number of neurons in each layer. Next, I'm gonna create the act method. So this will call the neural network to ask it to process these inputs and return the outputs. So this output method, it takes an ND array, so we have to convert this float array to an ND array, and there is a utility class to do that. So it takes also a 2D array with one row and length of inputs as columns, and it will return an ND array, so we have to convert it to a float array. Next, I need to create the crossover function. So the crossover function will take the second parent and it should return two children, so it will return a creature array. And the first parent is this. So to do crossover, there are multiple ways to do that. I'm gonna use the simplest one, which is single point crossover. So the single point crossover, first we need to define the crossover point. I'm gonna define it to be in the middle. Then we need to take the first half of weights of the first parent and the second half of weights of the second parent and combine them together to create the first child. Then we are going to do the inverse for the second child. So to know the number of weights of the neural network, both parents have the same number of weights because they have the same configuration for the neural network. Next, I'm gonna create two ND arrays that will be the weights of the children. So the shape of this ND array will be one row and number of weights as columns. Next, I'm gonna loop on all the weights of each parent, and I'm gonna divide them in half, and then I'm gonna do this algorithm. So we can use this method to put a value in a specific location. So we will always put it in the first row, and I'm gonna use I to put it in this specific weight column. And the value will be the parent weight at this specific location. I'm gonna do the inverse here. Lastly, I'm gonna create the two creatures from these weights. Next, I'm gonna create the mutate function, and the way it will work is that I'm gonna loop on all the weights of this creature, and I will have 5% chance for each weight to change its value to a random value between -1 and 1. Lastly, for this creature class, I will need to add two attributes. I will add a random ID for each creature and also the fitness of this creature. So now that I have the creature class, I will start working on the REST controller. I'm gonna call it Jan controller. So we will need to expose 4 endpoints, and I'm gonna use post for each endpoint. So the first population should return an array of creatures, but I'm gonna return a population DDO here. I'm gonna create in a second. The next population will also return population DDO, and it will not take any parameters. Next will be the act endpoint, and this we will need to pass the creature ID in the URL, and we will return act output DDO. I will also create in a second. So it has a buzz variable ID, this one, and we need also to pass a request body, and this will be act input DDO, and this should be the distance between the creature and the next obstacle. Lastly, for the update fitness endpoint, it will also have an ID bus variable, and it will not return anything, and we need to pass in the request body the fitness. I will create here fitness input DDO. Now I'm gonna go ahead and create these classes. So the population DDO should have an array of creatures, but to restrict what we return from the creatures, I will create another class creature DDO. So this creature DDO will only have the ID of the creature. So that's the only thing that I'm gonna expose in our endpoints. Next, for act output, so this should return the force in y direction to act on this creature, but I'm going to return a float array to make it generic. And for act input also I'm gonna accept float array, so that it will be easier later on to change these inputs and outputs. And lastly, for the fitness input, we should expect to get the fitness value. So to create the first population, first I will create a list here that will keep track of all the population creatures. So this is our state, and I will also have a variable here to define the number of creatures each population will have. And to create the first population, all I need to do is create 30 instances of the creature class. And I need to convert it to a population TTO. So population TTO takes a list of creature TTO, it doesn't take a list of creatures. So we have to convert each creature to a creature TTO. Next, I'm going to implement this act endpoint. And the way I'm going to implement it is, first I need to get the creature by ID, and then I will call the act method with the inputs, and I will return the outputs. So I will create a private method here to get creature by ID. And I'm gonna call the act method. And this will return the outputs, which I'm gonna construct act output DTO from. Now for the update fitness, I will just get the creature by ID as well, and then I'm gonna set fitness. And here I don't have to return anything. Now I will create this getById method. So the output is actually a float array. To create the next population, first I'm gonna move all creatures to a new list I'm gonna call dead creatures. Now I'm gonna loop on half of this population, and I will select two parents and cross over them together to create two children. I'm gonna mutate these children and then put them back to this creatures list. So to select two parents, for now I will just select the first two parents in the list. So now we should have here two children. I am going to mutate each child, and I'm going to add to the creatures list. Then lastly, I will return this creatures array, and also I have to convert it to population TTO. So I will create this in a method. So the last missing piece in this genetic algorithm is the selection algorithm. So there are multiple ways to do selection. I'm going to use this roulette wheel selection algorithm, and I already found an online implementation that I'm going to copy and use. I need to modify this a little bit to work on our application. So the selection algorithm will take the population, which is all our creatures, and should return two parents. So the way these selection algorithms work is that we give it all the population, and it will try more or less to get the best fit creatures and return them. And the way this specific algorithm work, I will leave a link in the description below that will describe it much better than I can. I will add here also a component annotation so that I can auto-wire in the controller. So we need to give it the population, which is dead creatures. And we need to return two parents. So now I'm going to write a very basic integration tests to make sure that this Java service is working. But I already actually found one bug. So for Jackson library to be able to construct a new instance of this class, we have to annotate the constructor arguments with JSON property. And we have to do it for fitness input TTO as well. Alright, now for the integration test, I'm gonna use bash. And I have this tool installed, HTTP IE. So this will help us make HTTP calls to our server. So first we are going to call this first population endpoint. And I'm going to pass here check status, which will fail in case it returns anything other than 200. Now I'm going to run our Spring Boot server. and I have to make it executable first, and if I run it, hopefully it will work. So it returns here an array of creatures, and if you remember, we only return the creature TTO, so we only expose the ID of this creature. Now for each of these creatures, I need to call the act method and update fitness. So I'm gonna use JQ to be able to select the creature's ID. So this will just return yes, creature's ID. I'm going to store them in an array. Then I'm gonna loop on each ID in this array. And I'm going to call the act endpoint. And we need to give it the ID of the creature and also the inputs, which should be a float array. Also, I'm going to call the update fitness endpoint. So the fitness should be just float. And I'm also going to pass check status. So it looks like it is working. Lastly, I'm going to call the next population endpoint. So that's it for this video. In the next video, I'm going to create the Unity project and call these endpoints. So hopefully it will be much more fun because we will start actually seeing something.